Hi, good afternoon, or actually, when y'all watching this, it'd be good morning, or good afternoon, good day to y'all. So, we're starting a new unit today. This unit, the overview of is called transformations. We're actually taking geometric figures, and we're sliding them and rotating them and reflecting them and dilating and reducing these things on a Cartesian plane. So this unit is actually relatively short, but I can't overstate its importance because the properties of transformations that you learn here in geometry is actually really important to understand for algebra 2. So you really need to dig into this. It's not hard. It's actually, I think it's kind of fun because you get to draw pictures and move things around and all, but it can be a little tricky at times. So with transformations, there's different. So I'm going to flip back to my little table of contents here. So transformations is like the big overarching idea. And there's different types of transformations. There's reflections, translations, rotations, and we talk a little bit about symmetry and all, and a dilation. I hate when people say dilation. Yeah, no, it's dilation. Um, that's the overview of this unit. Okay, so today what we're going to start to define what a transformation is. There's a couple other little pieces of terminology that I want to bring to light, and the particular one we're going to discuss today is a reflection. Okay, so let's just jump right in. I got my notes in front of me here, and also I'm going to be looking down a lot, but still talking to y'all, right? Okay, so let me turn on my little pen here. So some things you need to write down first off is so a transformation. It's an operation that maps an original figure called the hang on, my little pen's doing right here. I'm gonna use black. Okay, that's called the pre-image. Okay, so the pre-image is the figure you have before you do anything to it. If you're talking in an algebraic sense, we're talking about the parent function, if you will. On to a new figure called the image. So a transformation can change the size, position, or the orientation of a figure. So that's what a transformation is. It changes the size, position, or the orientation of a figure. So of the part here, pre-image. So pre-image again is the figure you have before you do anything to it. The image is the thing that you have after. Okay, um, so we're particularly going to look at the reflection transformation today. So a reflection is a flip over a line called the line of reflection. So each point and its images are right here, the same distance from the line of reflection. So here are some possible types of lines of reflection. It could literally be the x-axis, could be reflecting about the y-axis. Even some of these lines like x equals some number or y equals some number, like y equals 4, be like, so for like if I said the line of reflection is y equals 4, you go 1, 2, 3, 4. It's a horizontal line like that. If I said the line of reflection was x equals -2, if you remember, that's that line that stands up and down like this, right? So you go back 2, it's like this. So that could be that. Also, some other types of lines of reflection are the y equals x or y equals -x line. So these right here you might be a little fuzzy on this. The y equals x, that's the parent function of a linear equation, of a linear function. And real quickly, and they don't draw it on this, I'm just going to show you what it looks like. A y equals x line is this line right here. See, that's the y equals x line. So you might have some pre-image over here, and it will reflect over that line and be somewhere down here. Yeah, I should do object eraser for the line y equals negative x. Well, the only difference is that the slope is a negative, so it would be going through the origin again, but just going down like this. So you might have a pre-image up here somewhere, and it would reflect over here and be somewhere down in this area. So that's the gist of that. I already used that little object eraser there, so just do that right there. So okay, so that's the overall gist of this. So when we look here, let's start with this example. So I'm going to work a couple of these out, and then I'm going to turn it over to you and let you try the rest of them. So a triangle ABC has vertices at -4, 2, 1, 2, 3, 4, and 2. So a little side note. Well, no, hold on. So A and B is 4, 7, 1, 2, 3, 4, 4, 5, 6, 7. So there's B. And C is 1, 2, 3, 4, 5, 1. So there's C. So here goes nothing, right? Trying, you know me, and drawing. So boom. There. And there. Close enough, right? So I'm going to change my color here to do the actual image. So here's what it's saying. It's saying it's reflecting over the x-axis. So it's doing, boom, this. So what I need to do, so if it's reflecting over the x-axis, that means when I look at the x-axis and I go to a point, I'm looking at the vertical distance above, and I'm going to reflect at that same distance down. So here's what I'm talking about. So the point A, it is 2 units up, right? So when I go down 2 units this way, that's going to be right here. That's going to be my image. So that point A prime. Oh, by the way, I neglected to mention this earlier. So let me make this real quick. So a pre-image will just be like A, B, C. If it's a square, it'll be like A, B, C, D. You know. But the image will have this little apostrophe symbol right here, and that what we call that in math. We call it the prime. So the A prime is what that stands for. So A prime is the image, where the A would be the pre-image. Just a little side note there for you. So the ordered pair for A prime is -4, -2. So then I'm going to go up here. I'll do the B. So the B is, let's see, this distance right here. So 1, 2, 3, 4, 5, 6. That's 7 up. So that means it's going to be 1, 2, 5, 6, 7 down. So right here is going to be the B prime down here. So it's far up, it's down, right? Okay, so the B prime point would be 4 and -7. The C prime, well, it's only 1 unit up here, so it's going to be 1 unit down, so it's right here at C prime. So and I'm going to actually draw it in a little bit different color here, so here, there it is, and here. So, oh, I didn't even write the point for that, did I? Good Lord. That would be 5 and -1. My bad. So that is my reflected image over the x-axis. So your takeaway is, look, when I say reflected over the x-axis, is how far is that point away from the x-axis, and that's how much it reflects over it. Same thing applies if the line had been shifted, like if it's a different type of line of reflection. I'll show you one of those here in just a second. So let's do one where it reflects about the y-axis. So this time, my pre-image, I'm going to compare each point, how far is it from the y-axis, and I'm going to reflect it going that way. Okay, so let's get this thing grabbed here. So I'll do black for my pre-images and blue for my image. So -5, 1, 2, 3, 4, 5, 1, 2. So there's F. Oh, we're going to do a trapezoid this time. Okay. There's G. 1, 2, 3, 4, 5, 6. There's H. And -8, -6. 3, 4, 5, 6. Okay, so right here. So that's going to be I. So here we are. There we go. And whew, that's actually a good line. Okay, well, that might have been a little bit hard to see there, but there we go. So I'm comparing them all to the y-axis now. So do blue. So from G, so it's 2 units this way, so that means it's going to go 2 units this way. So that's going to be my G prime, which is a 2, -2. My F is 1, 2, 5 this way, so that's going to be 5 this way. So 1, 2, 3, 4, 5. That's F prime. H actually is not going to move because it's 0 units from the y-axis because it's a little line on it, so it stays put this time. So that worked out nice. So I is 8 units this way, so that means it's going to be 8 units this way. So 1, 2, 6, 7, 8. So right here. So H happens to be both H and H prime. Huh, how funny. So yeah. So to fill in these, because I want to point out a couple of things about the ordered pairs here. So F prime is 5, -2. H was 0, -6, and I was 8, -6. Okay. So here's something cool I want to show you that's happening here. So when it's reflecting about the y-axis, notice. So I'll use F as my example here. So F, look at its points and look at the pre-image and the image points. What do you notice different about it? I hope that you pick up on this. The y value happened to be the same thing, right? But the x value was a different. The sign changed, right? So when you're reflecting over the y or the x, and if you notice right here, look at G, and look at G prime. H, well now H and H prime in this case, you know, it didn't really do anything, did it? I and I prime. Notice that the only thing that changed was the x value. So we can make a little determination here. So let me let's make a little note. So so for reflection about the so reflect y-axis. So another thing I'll point out is that the notation I have right here is called vector notation. So when you what's happening here is that, so when I reflect about that, it's going to be a negative x and y. So what I'm telling you about this is that the x value negates itself. Is what happened. So it was a -5, but you negated a -5, and it became a +5. So there's that. So let's move on to. So you got those to play with. Let's see here. I'm going to do one of these lines of when x equals 4, but I'm going to leave the rest of them because you got the gist with the y line equals and x equals. It's going to kind of mimic what you did with the x-axis and y-axis. So let me go ahead and plot these points here. I guess I could make it a little bit bigger, couldn't I? So that's J. 1, 2, 3. So 1, 2, 3, 1, 2. Okay, we've got a triangle here. You know, I didn't make. I need to go back and make a point here in a second. That's okay. So there's that. I want to reflect about this line. So here's what I do with those lines of reflection when it's not the x or y axis. X equals 4, 1, 2, 3, 4. So I'm going to actually do a little dotted line. So I'm like, oh, okay, this is the line that I'm reflecting about. So I'm going to check the distance from that line this time. So K is 2 units to the left. That means K prime will be 2 units to the right. J is 1, 2, 3 units left. That's going to be 1, 2, 3 units right. And L is 1 unit left. That means 1 unit right. So there's your reflected figure. One point I forgot to make on this one. All right, so I made the point on this right here. I did not, however, make the point on this one. So let's go back to that real quick. Sorry about that. I'm scatterbrained, so you just gotta love me through it, right? All right. So take note of like your A value, your pre-image point A, and look at your A prime. Notice this time that the x value is the same, but the y value is negated. So and you'll see that on every one of them. So what you can conclude from this is that when it's about the x-axis, so the vector format right there, x, y, that's representing the pre-image point. It maps, so the little arrow like that means to map onto. It's going to leave the x value alone, but it's going to negate the y value. Okay, so that's the transformation property for that. Let's see, does it have? Okay, so I'm going to show you two more. I'm going to show you the line when the line of reflection is like the y equals x line and the y equals negative x. So the y equals x. So when I see these, I immediately, just like I did on the previous one, I go ahead and draw that little dotted line. Okay, so that's my line of reflection there. So here's what's going to happen. I'm just going to go ahead and write the property out. So it's going to map, and here's what's going to happen. You're going to actually take the y and x value, and you're going to swap them. So your pre-image point, you got this x and y values, you're going to take them and you're going to turn them around. So check this out. It's kind of cool. So 1, 2, 3, 4, 5, 1, 2. That's x. 1, 2, 3, 1, 2, 3, 4. That's y. Negative 1, 1 is z. So boom, boom, and boom. Okay, so here's my pre-image, my image. So the x value was was negative 5, negative 2. So now I'm going to make it negative 2, negative 5. So I'm going to go down 2, 4, 5. That's going to be my y prime. Okay. My z, I'm sorry, let's do this in order here. Okay, so y was negative 3, 4, so that's going to be 4, negative 3. So 4, negative 3. 1, 2, 3, 4. 1, 2, 3. So that's going to be my oops, I think I made a mistake. I think I had a moment there, guys. I might have had a senior moment there. Negative 2. 2, 3. I'm sorry, that is my x prime right there. I just call it the wrong thing. That's my x prime. My y prime, 1, 2, 3, 4, 1, 2, 3. And then my z prime, which would be 1, negative 1, because I swapped those around. My bad, guys. I'm sorry. I'm just doing these late in the afternoon, and I just overlook things sometimes. Oh my goodness. Oh my. And you know what? I made another mistake. I wish y'all were actually in class with me right now, because you would have called me on this. -2, -5 is not in the fourth quadrant. So, hey, that's okay. That's okay. Easy fix. The eraser will take care of that. All right, so that is the reflection about the y equals x line. So your big takeaway there, is that right there. Now let me do one of the y equals negative x. So this one you got to be more careful with. Okay, so here's what's going to happen. You're going to have your pre-image, and when you map it, so what's going to happen is you're going to swap the y and the x just like you did before. However, you're going to negate both of them. So hang on, my little thing's being crazy here. So it's going to be negative y and negative x. So here's how that works. So black for the pre-image there. -1, 1, 2, 3. It's A, B, 1, 2, 3, 4, 5, 6. 1, 2, 3. 1, 2, 3. There's that, and 2, 2. C, D. So got us a little square here. So if I'm going to go over the line y equals negative x, that's the line doing this right here. So it's that line. So every point is going to be flipped and negated. So for A prime, that's going to mean it's going to be a -3, +1. The B value is going to be a -6, 0. That's going to be a -5, -3, and a 1. I'm sorry. -2, -2. Don't know where that came from. So when I plot those, 1, 2, 3, 1, there's that one. So this is going to be your A prime, B prime, 1, 2, 3, 4, 5, 6. B prime, 1, 2, 3, 4, 5, 1, 2, 3. C prime and -2, -2. That's your D prime. Well, you get the idea. Okay, so and once you see it drawn out, you can see the symmetry quite well. So I'm going to stop there. So you have everything you need to be able to do the remaining on this sheet. So your assignment's going to be to complete 2, 4, 6, 7, 8, 10, and 12. So if you don't finish them in class, that means that you'll need to do them for homework. Just make sure you have them ready for the next time we see each other. So good luck, and I apologize for some of those mistakes. And just late in the afternoon, my brain goes dead. So don't worry, you'll get there too one day. So happy studying. Hope y'all have a great day. Bye bye.